Welcome to video 3 for this unit on Pythagorean theorem and irrational numbers. In this video, we're going to focus on the Pythagorean theorem. A right triangle is a triangle with a right angle. In a right triangle, the side opposite the right angle is called the hypotenuse, and the two other sides are called its legs. Here are some right triangles with the hypotenuse and legs labeled. We often use the letters A and B to represent the lengths of the legs of a right triangle, and C to represent the length of the hypotenuse. The hypotenuse is always the longest side of a right triangle. Now let's consider three different right triangles and the relationship between the lengths of the sides. Notice for these examples of right triangles, the square of the hypotenuse is equal to the sum of the squares of the legs. In the first right triangle in the diagram, 9 plus 16 equals 25. In the second, 1 plus 16 equals 17. And in the third, 9 plus 9 equals 18. Expressed another way, we have a squared plus b squared equals c squared. This is a property of all right triangles, not just these examples, and is often known as the Pythagorean theorem. The Pythagorean theorem describes the relationship between the side lengths of any right triangles. The name comes from a mathematician named Pythagoras, who lived in ancient Greece around 2500 BCE. But this property of right triangles was also discovered independently by mathematicians in other ancient cultures, including Babylon, India, and China. It is important to note that this relationship does not hold for all triangles. Here are some triangles that are not right triangles, and notice that the lengths of their sides do not have the special relationship a squared plus b squared equals c squared. That is, 16 plus 10 does not equal 18, and 2 plus 10 does not equal 16. The figure shown here can be used to see why the Pythagorean theorem is true. Both large squares have the same area, but they are broken up in different ways. These matching areas help us see that when the sum of the 4 areas in square F are set equal to the sum of the 5 areas in square G, the result is a squared plus b squared equals c squared, where c is the hypotenuse of the triangles in square G and also the side length of the square in the middle. The Pythagorean theorem is true for any right triangle. If the legs are a and b and the hypotenuse is c, then a squared plus b squared equals c squared. This property can be used anytime we can make a right triangle. For example, let's use the Pythagorean theorem to find the length of this line segment. The grid can be used to create a right triangle, where the line segment is the hypotenuse and the legs measure 24 units and 7 units. Since this is a right triangle, 24 squared plus 7 squared equals c squared. The solution to this equation and the length of the line segment is c equals 25. The Pythagorean theorem can also be used if the length of the hypotenuse and one leg is known, and we want to find the length of the other leg. Here is a right triangle, where one leg has a length of 5 units, the hypotenuse has a length of 10 units, and the length of the other leg is represented by g. We start with a squared plus b squared equals c squared. make substitutions for the values we know, and then solve for the unknown value. For this triangle, the hypotenuse is 10. So 5 squared plus g squared equals 10 squared. We can now use estimation strategies to know that the length of the other leg is between 8 and 9 units, since 75 is between 64 and 81. A calculator with a square root function gives the square root of 75 is approximately 8.66. Thank you for watching video 3 of 5 for this unit on Pythagorean theorem and irrational numbers.